Good afternoon. I'm going to talk you through how to solve Philip Newman's Shot Through the Heart puzzle, which is a palindrome killer Sudoku, which was released as today's genuinely approachable Sudoku in our daily Sudoku channel. The reason I'm recording this is because we expected this to be a puzzle which would cause a slight variance in solve times, as it requires some very narrow thinking about the palindrome and the cages therein. And we figured there might be some newer solvers who may not be all too familiar with how that all operates. So I figured it might be a good idea to show you how I would go about this puzzle. Now I have already solved it. I tested it a while back. It looks slightly different. The cage orientation in the middle was slightly different from what it is today. We found that version to be a bit steep towards the end of the solve in difficulty. So Philip reworked it into this excellent puzzle which flows really nicely and has a really elegant logical path if you manage to find it. So let's get into it. Where you would start in this puzzle is ideally on the palindrome and the killer cages. You might, based on intuition from earlier killer puzzles you may have done, you might want to look at, for instance, a box like this, where the remaining cells have to sum to 45 minus 16 minus 17, which is 12. Or you want to look at this row where you can do the same operation on these three cells. But that's actually not the way into this puzzle. The way into this puzzle is to follow the palindrome from the outside all the way to the inside. Now, and you'll want to start with two cells that are in the H cage here. An 8, the maximum digit you can put into it, the highest digit is a 5. So you would get 5 to 1, for example. And that gives you 1, 2, 3, 4, 5 on the palindrome. Now, if you pencil mark those cells into the other end of the palindrome, you don't need to do any coloring or cell counting, and indeed I'm not going to make use of that at all during my solve, and you'll find out why. But once you pencil mark these cells onto the palindrome, you'll see that one of those is in a 22 cage. Now, similarly, the highest digit, the highest digit you can put in an 8 cage is a 5. The lowest digit you can put in a 22 cage is also a 5. And that would have to be paired with an 8 and a 9 to reach 22. That gives you a 5 on the palindrome and reduces these cells in the 8 cage to 1 and 2. And this cell on the other end of the palindrome to a 1 and 2 as well. Now this 8, 9, when you then pencil mark that into the 15 cage, you can see you've got a 1-2 pair looking at that 15 cage, which means the minimum value of these two cells is 3 and 4, which is 7. And indeed, 7 plus 9 would be 16, and that would violate the 15 cage. So this must be an 8, this must be an 8, this must be a 9, and these have to be minimal and are 3, 4. 6, 7, 8 goes into the remainder of the row. We can't do too much with that just yet, so we're not going to spend too much time looking into it. But we've got this 3, 4, and maybe you've already caught on to the logical theme. We're just working our way along the palindrome. So we're just going to pencil mark this 3, 4 in the 17 cage and see if it has any effect. Now let's consider if this is a 3, we need 14 more in the 17 cage in 2 cells. That could be 8, 6 or 5, 9. But we have an 8 and a 9 looking at both of those cells. So we know this is not a 3, this is a 4. That resolves the 15 cage. And we now need 13 more in the 17 cage, which can only be made in one way, and that's with 6 and 7. Now 6 and 7 goes on the 9 cage, and a 7 would have to be paired with 2 1s or 2 and a 0, which is not allowed. So this has to be a 6, which resolves the 17 cage, and we get a 1-2 pair in the 9 cage. Now let's see what that 1-2 is doing. That is being placed into a 19 cage. You can never have a 1 in a 19 cage because it would require double 9 or digits higher than 9, which is not allowed in this puzzle. So this has to be a 2. And you can see we're really working along the palindrome. This goes with an 8, 9. Removes 8 from the 11 cage and places an 8, 9 in the 20 cage, and we've got an 8 looking at that particular cell. So this has to be a 9 and this resolves the 19 cage. Now we need 11 more in this cell. I don't believe we can resolve that yet at this point. It can't be 5, 6 or 2, 9, but it could still be 3, 8 or 4, 7. So this is the first part where you need to look elsewhere in the grid to start making progress. And let's see if we can find where that is. So at this point you might start pencil marking a few values, like for instance this 6 has to go in one of these cells, this 5 has to go in one of these. But the real place you want to be looking at is in this case box 6, where we've now got 16, a 16 cage left to fill. We filled a 17 cage, that adds to 33, and we've got an 8 in the box, which adds to 41. Now 45 minus 41 is of course 4, and 4 in 2 cells, which are the 2 remaining cells which we've not looked at, has to be made from 1 and 3. Now that puts 259 in this cage. You can see we've got a 2 here and a 5-9 pair here. This 2 looks nicely at the palindrome, so we get a 1, 1, 2. And we've made a bit more progress. Sorry about that. Now from here we need to find another place to make progress. And I can see we've got a 1 now in the 16 cage, so we're going all the way back to the start, where we need to place 15 in the 2 remaining cells. They can't be from 9 and 6, since there is a 9 in the box, so they have to be from 7 and 8, and we've got an 8 looking at one of the cells, so we can place an 8 here, 7 here, which is on the second palindrome, and now we've got 7s looking at these 2 cells, so we actually know that the 3-cell palindrome is in fact made of 3 7s. Gives us a 6 here. Now if we look at the 22 cage, that always has to include a 9. We need 15 more in the 22 cage, so it has to be made from 6, 9 in this case. We've got a 6 here, place a 6, 9, 9, 5. Now we pencil marked 5s in here, so we can place those. And we can continue looking at the 7 cage, which needs 4 more. Now similarly to here, 4 has to be made from 1 and 3. We've got a 1 here, so we can place 1 and 3. Now looking at row 4, we need 3 and 4. You've got a 3 here, 3 and 4. And we now need 7 and 8 into the remainder of the box. You can see we've got a 7 here. And we've now suddenly placed 16 in the 20 cage, where we need to place 4 more. So we can place a 4 along the palindrome. So you see, you really want to be staying with the logic when you find it, seeing what other deductions can you derive from the digits that you just placed. Now you've got one more cell in row 5, which is free, and you've got a 2, 4, 8 triple in box 5. Let's just note that in. This can't be a 4, this can't be an 8. Now a couple places you can make progress. First off, you can see that the 9 has to have 5 more. It can't be from 1, 4, so it has to be from 2 and 3. A 10 cage can never have an 8, so you actually get an 8 in the 15 cage, which now needs 7 more. Making 7 in these 2 with these candidates is only possible in one way. That's 4 and 3. Gives you a 1 and a 2. Places the 2 here, the 3 here. And we need 1, 5, 6 and 7 in this box. We've got 1 and 6 is looking at the box nicely, so we can place a 6 here, a 1 here. Now we've got 3 in the 10 cage, so we need a 7 with it and a 5 here. And from here it's just classic Sudoku. We've actually resolved the palindrome and the killer cages entirely. And you can see that flowed really nicely throughout the solve. We really progressed along the palindrome, and we only had to revisit to resolve the one once in the solve. Now to resolve the classic part of the remainder of the solve, that's just scanning. So where I would start with scanning in this case is box 2, where you can see we've got 3 rows with 7 digits. This one needs 4 and 8. We've got an 8 here. This one needs 2 and 5. We've got a 5 here. And now we need 3 and 9. We can't resolve that yet, but this 3, 9 would be very restricting in row 2, where we still need to place a 6. And we've got 6s here. Now, when you look at this column now, where you've just eliminated one more cell in box 3, this 2, where does it go in in column 9, can only go here. To complete this box, you need 3 and 4. You've now suddenly got column 7 with 7 digits filled, which needs a 1 and a 5, and indeed there's a 1 and a 6, and indeed there's a 6 here, so you can resolve that. Now let's just see, this one needs 3, 7, and 9. We've got 3, 9 here. Can't do the 3, 9 yet. 4, 5, 8 in here. We've got 4 and 8 here and 4 here, so you can write those in instantly. 1, 5, 8 in here. Now we've got values everywhere, which means we can do that quite easily. 5, 8, 1. We need 3, 6, and 9 in here. We've got 3s and 9s here. 3, 6, and 9, it means we need a 2 and a 7 to place in here as well. We've got 2's here, and we've got a 7 here. Now we can do this row where we need a 7 and a 6. Then the box 1, 9, 9, 3. And you can see the rest is just write-ins. So that's how I would go about solving this puzzle. Like I said, took me around 4 minutes, I believe. And it's really just a matter of honing in on the palindrome. So finding that restricted place in the puzzle and then not letting go, because you can see the logic really flows elegantly from every deduction you make. So I hope that was informative, and I hope you enjoyed watching that, and see you next time.